Hello students, welcome back to our today's video class. Your exams are over. Now you are going have to get prepared for your next unit test 4, and then after final term. As we are doing hydrogen chapter, we will continue in this video also. In the last video class, I have explained you up to uses of hydrogen gas. Now, today's topic is the oxidation and reduction. Before going to the main points of this oxidation reduction, we will see what is actually oxidation and reduction. Oxidation and reduction. These are the two things, okay? Oxidation and reduction. The chemical reaction in which either oxygen is added or hydrogen is removed. If in a reaction, if hydrogen is removed or oxygen is added, then the reaction is called oxidation reaction. It is the main definition of the main concept of the oxidation and reduction. Okay, so first of all, in oxidation, here addition of oxygen and removal of hydrogen. Oxidation of hydrogen means addition of oxygen and removal of hydrogen, whereas in reduction it is addition of hydrogen whereas removal of oxygen. Just opposite. It is just opposite. So that means addition of oxygen means it is also called gain of oxygen, and removal of hydrogen it also means the loss of hydrogen. Suppose, for example, if you see one by one, first of all we see the addition of oxygen. That is, if you take carbon plus oxygen, it gives carbon dioxide. So what we see here, oxygen is added to carbon to form carbon dioxide. So it is a type of oxidation reaction. So there are other examples are also there. Suppose sodium Na plus O2, it gives Na2O. It gives Na2O. Okay, sodium oxide Na2O is another example of oxidation reaction. Okay, so when you balance them, you can balance it also. After that, the removal of hydrogen means hydrogen should be removed from a compound so that it becomes a oxidation reaction. For example, when from hydrogen sulfide H2S gas is heated, reacts with chlorine Cl2. Chlorine will react with sulfur to remove hydrogen. Okay, sorry, chlorine will react with hydrogen, means chlorine is removed from the sulfide, so to form HCl, and sulfur gas is separated. Okay, so chlorine will react with hydrogen, means hydrogen is removed from the sulfur, so ultimately it forms hydrogen chloride and sulfur is removed. Okay, so what we see here, hydrogen and sulfur, hydrogen is separated from the sulfur. So it forms here it is a removal of hydrogen. We can see here. Similarly, hydrogen iodide Hi. If you take hydrogen iodide with again chlorine Cl2, what you will get? Again HCl you will get, and iodine will be separated. Okay, iodine will be separated. In this way you can see. So we have to balance it here. It is balanced now. Here also we have to balance. That's it. So again you can see chlorine is helps hydrogen to remove from iodine. So removal of hydrogen takes place here. So it is a again oxidation reaction. Next, the reduction reaction. Thus opposite the addition of hydrogen and the removal of oxygen is called reduction reaction. Okay, means loss of oxygen and gain of hydrogen. You can also say loss of oxygen and gain of hydrogen. Now here first of all we will see few examples. HgO when it is reduced to form mercury and oxygen. Okay, mercury and oxygen. So what we see here, while the reduction of when you decomposition of mercuric oxide you takes place, when the reduction of mercuric oxide takes place, so mercury and oxygen is separated. So here what we see, oxygen is removed from the mercury and it get the two compound elements, hydrogen and mercury and oxygen. So here what we see, the removal of oxygen takes place. So it is a reduction reaction. So it is the example of removal of oxygen. Now we will see the addition of okay. So when hydrogen reacts with sulfur to form hydrogen sulfide gas. Hydrogen sulfide gas. What we see here, sulfur is reacts with hydrogen to form hydrogen sulfide, which is again a addition of hydrogen takes place. So it is a reaction of reduction reaction, addition of hydrogen. Similarly, in so many examples we will see reactions, both this oxidation and reduction takes place. Both oxidation and reduction takes place. Those type of reactions are called as redox reaction, means the some simultaneous happenings of reduction and oxidation in a single reaction. It is also called as redox reaction. Half reduction, half oxidation makes a redox reaction. So we will see now the redox reaction, and few examples we will see to understand the redox reaction. Let us see. Now next point is our redox reaction. Redox reaction. What is redox reaction? A reaction in which oxidation and reduction takes place simultaneously is called a redox reaction. So first of all we will see how the redox reaction takes place. For this we will take an example. Suppose PbO plus H2. It gives Pb plus H2O. It gives Pb plus H2O. What we see here? Here hydrogen reacts with oxygen to form water and lead is separated. Okay. Now when hydrogen is added to oxygen, what happens? When hydrogen is added to form oxygen, so the addition of oxygen takes place. So what happens when hydrogen forms to water with the addition of oxygen? So here we can see addition of oxygen takes place. So it is an oxidation reaction takes place. Whereas again when hydrogen helps to remove oxygen from the lead, so lead transform to lead oxide, it forms to only lead. So what we see here, lead oxide is changes to only lead. Here the removal of oxygen takes place, so it is the reduction reaction. Here is takes a reduction reaction. So ultimately you can see in this reaction both oxidation and reduction takes place. Hence the reaction of lead oxide with hydrogen to form lead and water is a redox reaction. So there were now the next point is oxidizing agent and reducing agent. Oxidizing agent and reducing agent. What do you mean by this? Oxidizing agent and reducing agent? Agent means what? The mediator, you can say. Here the substance that brings about the oxidation reaction is called oxidizing agent, and the substance that brings and about a reduction reaction is called a reducing agent. Okay, so what we see here, oxidizing and reducing agent. So in this here what we will see, the example which we have taken here, lead oxide loses oxygen to form lead. Okay, so and get reduced to form lead. So while hydrogen gains oxygen, to form water. Okay, so hydrogen oxidizes to form water. So we can say that lead oxide combines contribute oxygen to share with hydrogen to form water. So ultimately we can say lead oxide is a oxidizing agent. So lead oxide is here, PbO is a oxidizing agent because lead oxide helps hydrogen to combine with water or oxygen to form water. So lead oxide is a oxidizing agent here. While when this happens, simultaneously what happens, this hydrogen helps oxygen to get removed from the lead oxide to form water. So here reducing agent is hydrogen is the reducing agent. So you can see how the reduction and oxidation reaction takes place and what are the oxidizing and reducing agents in here. Another example of oxidation and reduction of loss of gain electron is you can see vast examples of are there. So oxidation and reduction losses and gain electrons. Oxidation is also defined as loss of electron. Oxidation is also defined as loss of electron of an atom to form an ion, and reduction is a gain of electron to form an ion. For example, here is given one example, zinc plus chlorine, it gives zinc chloride, what happened here? Zinc lost 2 electrons to form zinc ion. This is the oxidation, whereas chlorine accepts 2 electrons, or means gains electrons to form electronegative ion. So it is a reduction reaction. So above reaction, both the things happens, oxidation and reduction. So ultimately this example is also we can say as a redox reaction, whereas chlorine reduces to form zinc. So zinc is a reducing agent, while oxygen oxidizes to zinc chloride, which helps zinc help chlorine. So chlorine is a oxidizing agent. Okay, so we will see these things on the board. Let us see the thing. Okay, how the loss of electron and gain of electron forms a oxidation and reduction reaction. Suppose the example that it is given, that is zinc plus Cl, Zn plus Cl, it gives ZnCl2. Okay, it gives ZnCl2. Okay, so it is ultimately balanced chemical equation. So what happens when zinc and chlorine, as you know that by the number of electron exchange, we can say how the zinc and chlorine is formed. So in outermost shell, zinc is having 2 electrons, where chlorine is having 7 electrons. That means if zinc lost one electron to form and give chlorine one electron, then they will become stable, means they will attain the nearest electronic configuration of the noble gas. So here zinc will lose 2 electrons and chlorine will gain 2 electrons. So what we see here, zinc is losing 2 electrons. Zinc is losing 2 electrons to form Zn2 plus, a positive ion. So what happened? What we see here, zinc lost 2 electrons to become electropositive ion. So by losing electron, it become electropositive ion. So here it is a oxidation takes place. Here you can see, here oxidation takes place by losing electron. Whereas chlorine, what we see here, in the case of chlorine, what we see, it will gain 2 electron to form Cl2 minus. Cl2 minus, sorry, 2 it will be here. Okay. So that means what we see here, chlorine gains 2 electrons to form chlorine ion, which is electronegative ion. So by since it gains electrons, so it is a reduction reaction. It is a reduction reaction. So now the question is, who are here the oxidizing agent and reducing agent? So oxidizing agent, what we will see? Oxidizing agent and reducing agent. So what are oxidizing agent and reducing agent here? So zinc and chlorine ions are combined from zinc chloride here. Here chlorine reduces. Okay, to gain 2 electron from the zinc. Okay, that means it reduces zinc to form oxidation, means removal of 2 electron is helping. So oxidizing agent is here zinc, whereas zinc is the oxidizing agent is the chlorine is the oxidizing agent, because if chlorine helps zinc to lose electron, then only chlorine will gain 2 electrons. Okay, so the oxidizing agent is here chlorine, whereas zinc, if zinc don't lose electron, chlorine will not get 2 electrons. Since it losing electron and helps chlorine to take my 2 electrons, so zinc is helping to form reduction. So zinc is the reducing agent. So in this way we see chlorine reduces with the help of zinc, whereas zinc oxidizes with the help of chlorine. So chlorine is the oxidizing agent, whereas zinc is the reducing agent. So this is all about your hydrogen chapter. So here our chapter is completed. Now it's time to continue with some important questions I will discuss with you in the next video class of this exercise. So before that, go through the chapter once again properly, and if you get any doubts in this, you can ask me in your online classes, okay, or you can text me. Thank you very much for watching this video. I hope you have enjoyed this video. Thank you very much.